When we watched the video over break, folks, or you might have done it on Tuesday, okay? When you watched the video, we talked about binary molecular compounds. So, we know binary is 2. Okay? What does molecular compounds tell you? It is covalently bonded. Excellent. Okay? All the way back to remember covalent bonding. So if we're talking about covalent bonding, we're talking about what type of elements? Huh? Nonmetals. So, when we look at these, we should first try to identify, okay, I have 2 nonmetals. Okay, 2 nonmetals. Can I have more than 2? Okay, it wouldn't be binary, would it? No. So, when we look at these, we're talking about covalently bonded molecules, so we are talking about 2 nonmetals. We have 2 different systems. One is the newer system, the stock system. You will learn that later on in this chapter. Okay? We need to know about oxidation numbers to do the stock system, and we won't do oxidation numbers for a few days. I don't even know if we'll get to it this week. But later on in the unit, we will talk about oxidation numbers, and we will use a stock system. Now, you've already used a stock system dealing with cations. Okay, we used a stock system dealing with cations, so you will use one dealing with these binary molecular compounds also. And those stock system is just the Roman numerals, if you remember that. Okay. The old system of naming molecular compounds uses prefixes. So what's a prefix? Something that goes on the beginning, the beginning of the word. So we will use prefixes, okay? And we have some rules that we follow when using these prefixes. First of all, the least electronegative element is given first. When we do that, we use the actual name of the element. It is given a prefix only if it contributes more than 1 atom. Okay, we're going to work some more examples. You probably worked 3 or 4 examples. We're going to work some more here today once we get reviewing this, and I'll show you this. But the first element, if there's only 1 of them, do we use a prefix? No. All others, yes. If there's just 1 of that particular element, no prefix. The second element is named by A, taking a prefix that indicates the number of atoms of that element, B, taking the root of that element, and C, adding an IDE ending. So prefix, root, IDE. So, with few exceptions, and there are a few of them, okay, but with few exceptions, if something ends in IDE, it indicates that it's binary, that it has 2 elements. So, if you get that thinking, for the most part, that's right. There's a couple of polyatomics that end in IDE, so it's not totally correct, but for the most part, yeah, that is correct. Okay? So prefix, root of the word, IDE. If there is an O or the A at the end of the prefix, we usually drop it if the element begins with a vowel. Okay? So, if I have monoxide, I don't put MONOXIDE. I don't double O it right there. I take that O off. Okay? I don't say pent oxide. Since that O's there, I take that A off. Does that say anything in this rule about an I? So could I do dioxide? Could I do that? Absolutely, that's the way it's done. Now here's one. What do you think about this? Triiodide. That looks funny, doesn't it? It looks funny, but that's how we do it. Okay? That's how we do it. Because we only do for an O or an A. Now, I believe that we're going to talk about the prefixes now. Here are the 10 prefixes that you need to memorize. Mono is 1, di is 2, tri is 3, tetra is 4, penta is 5, hexa is 6, hepta is 7, octa is 8, nona is 9, and deca is 10. So, you should already have these copied down in your notes. Okay? You should already have those down. And the examples that you worked. We're not going to work those examples again. That would bore me too much. So I have some examples that we're going to do here. The first one is carbon tetrachloride. Now, I know, based on my rules, that carbon is the least electronegative. Chloride is more electronegative. So, how many carbons do I have here? What is my prefix? There is none. So what does that tell me? That I have one carbon. So, I would write carbon. What is my second element? Chloride, which is chlorine. How many? 4. So there, folks, is carbon tetrachloride. Here's my second one. Tetraphosphorus decoxide. Break it down. I know that I have phosphorus. What's my prefix with phosphorus? What's my prefix? Tetra, which is 4. I know my second one is oxygen because of the oxide. How many oxides do I have there? 10. So P4O10 is tetraphosphorus decoxide. Now, one question you might ask yourself is, do I need to reduce these? Because I could reduce that taken out of 2, couldn't I? Don't reduce them. Okay? We do not reduce these. My third example, dinitrogen monoxide. Nitrogen, how many? 2. Oxides, how many? 1. Okay. So we do put the mono on the second element. Dinitrogen monoxide. Let's go the other way. Okay, let's go the other way. Let's write the name. What is my first element here? Carbon. We write it exactly as so. Carbon. Do I need a prefix on carbon? Do I put mono on my first word? Do I? No. So I don't have anything. What is my second? What is my second element? Bromine, but I have to IDE it, right? So it would be bromide. And how many bromides do I have? 4 of them. I have tetrabromide. So the correct name for CBr4 is carbon tetrabromide. Now, let's look at this one. What do you think about this one? Diphosphorus. What's my second one going to be? Trioxide. Diphosphorus trioxide. Now my final one, folks, right here. Right here is where the rub is. Because if you write this down, excuse me, if you write this down when you start doing this, here's how people do it. Okay? Here's how people do it. Barium, sulfur, trioxide. Now, the problem is that when I come back up here, am I dealing with 2 nonmetals? No, this is a metal. Barium is a group 2 alkaline earth metal, right? So this is an ionic one. So that's the trouble when we get to doing these, when I throw them all together. You have to distinguish which one it is and which way I'm going to name this. So the correct name for this is barium sulfite, because the SO3 is a polyatomic ion. So that'll be on PAL. So this is ionic, and people try to name it covalently. I always throw one of those in there just so you can see that you just can't do things one way.